Okay, so my testing with brass is complete. It's time to move to titanium. I'm trying to remove the piece of brass from the bar feeder and put the tie in, but when I click the unclamp button, there's something stuck in the bar feeder, and I've been at it for 20 minutes now trying to figure out what's colliding. But I'll show you guys here. If I click this button right here, the unclamp button, first you'll hear the noise. That's not a good noise. So I don't know what's... Something's stuck. Something's going like this. So I'll do the same thing again. It's going to make that loud noise. 3, 2... Something's stuck. I don't know. We'll figure it out. So the alarm that it gives is booster clutch engagement failure, which is good. It sounds like there's a clutch that says, whoa, too much force. I'm gonna, break the connection for a second. That's a safety valve, so that's what's happening. But everything's air pressurized, so everything's closed. So I don't know how to open it up yet to be able to see where the stuck is. Yeah, so I'm just fiddling. I tried turning the air pressure off, still didn't open anything, so I just got to keep poking away at it. Maybe call LNF service and just see if I can get a tech guy on the phone for a few minutes. It's probably super easy. But yeah, that's where I'm at right now. Other than that, the screws have been perfect. A lot of testing, a lot of tweaking. I already filmed a lot of that. But I have made perfect screws. In case it wasn't obvious, I have to be careful what's obvious to me and maybe not obvious to you guys. We're using brass to test because I don't need coolant. I can see what's happening. Brass cuts like butter. The tools don't wear out. It's really nice to be able to see and visualize, and yet it's still a metal. So when I move to titanium, everything's going to be pretty much the same. Tolerances might be a few tenths different. I don't know, but brass is an amazing test material because it lets you play and not worry too much. Because it's super easy to cut. You don't need coolant, and it's cheap. So yeah. Testing with coolant on would be a nightmare because I can't see what's happening. I can move it forward and back about, 2 or 3 inches, and then it hits something. I don't know if it's hitting here or if it's hitting on that end. I'm trying to figure that out right now. I wish I knew how to open this cover right here so that I can see if it's the end of the bar that's hitting something. I don't know. Calling service. I got it figured out. So I turned the air pressure off, which allowed me to lift this whole tray that I couldn't lift before. This kind of supports the top of the bar in this round groove channel. So I was able to lift that, and what's happening is the end of the bar is hitting on that black spacer thingy, because from my fingertip to almost to the end of the bar here is an empty channel where a remnant will drop down and show up in here. So those are the remnants that are too small to be machined. I haven't measured them, they're like 9 inches. Whereas on the Nakamura I can have a remnant that big sometimes, but on the Swiss, because of everything, you need a remnant. So there's that little gap right there. So as it's trying to push the bar forward to clamp this thing down and pull the collet off, the bar is dropping and hitting that front of that thing. So normally you would put a large chamfer on the front of your bars, but because we've been machining this part, it's flush, right? So I might go in and change my cut-off routine, my part off, to have a little tiny chamfer, or maybe a big one like that, if it doesn't affect the parts that I'm making, so that this never happens again. And it's only going to happen with a bar that's like 10 inches long, 11 inches is fine, shorter, and it'll just eject itself. So this is a bar that still has maybe like 5 parts left or something, and that's kind of the only scenario where this is going to be a problem. But, so what I did is I pulled out this little pin, which should allow me to Can't do this one-handed. Aaron has already gone back to editing, so I'm on my own here. Actually, you know what's happening is it fell down the channel again. Okay, that's all I gotta do. It should come right out here. Ta-da! Got it out. So this is the gripper collet. It slightly expands and it's grippy on the inside, so it holds the bar. So I have to manually remove that and then put the collet back in the machine and then put some tie in and it should be good to go. I just realized, you know what I'm going to do? I'm going to put a chamfer on the end of that bar, put it back in the machine, let the machine do what it's got to do. I bet you that'll work fine. Alright, let's try this again. Click the unclamp button. It's thinking. Bar stock is moved. Yeah, buddy. Clamping it. It pulled it out. Checking to see if it's still there. Yeah, there we go. So there's my offender right there. Little chamfered end, and he was falling. Love it. Now I can pull it out. It works! It works! It works! So that's what it looks like with coolant. Can't see what's going on, but it works.
We already have one recorded sound effect created by me.
Today's sound effects brought to you by Yo Van Rosen.
What's that?
We need like reality
That's me
TV
right
show
now.
cameras everywhere around
Man,
the
I'm
shop.
like a dog.
Constantly recording.
Like, huh? It looks like me. Good thing I didn't try to fight your phone. Who's that?
All right, let's go see the knife-pocalypse upstairs.
Let's go check it out.
So I'm about a week behind on screws. Haven't had them, been struggling with this, but I'm so glad I got it. So let's check this out. All right, show me the knife-pocalypse.
All right, so usually this bin right here has like 6 sets of handles in it. You can see it's like completely rammed full.
Nice.
We had some overflow, so you'll see some sets down there under that hat. And if you look over here at my workspace, bunch of handles there. Then we've got 8 more sets in the tumbler right now.
Never have I seen so many Norsemen in one place, ready to be finished.
And it's all about this guy right here.
Yeah. Nice. So you're saying a lot of screws to make.
Yeah, need about 200 screws right now to have those.
All right. At a minute and a half each, shouldn't take too long. So do you want them in like 10 at a time batches? Or
Yeah. 7 to 10 would be great.
Attempting to film inside. Ugh. Couple more. Going good. You can kind of see what's going on. Watching this lathe do its dance. All right. Turn the screen on. So far we've made 20 good parts. I put a 1500 limit on there. Just, I don't know if I'll get that high, but remaining parts 1486. And I think this is just an overall counter for a while now. Cycle time 75 seconds. That's a minute 15. Super happy with that. They were almost 3 minutes on the Nakamura. So definitely twice as fast. Look at this thing just eat up code. Path 1, path 2, they're like 2 machines separate. This is where it's milling the Torx pattern. That high-speed spindle right there. Electric spindle. So we got 17, almost 1800 RPM, no torque. So I got a lot more torque capacity on that tool, which is good to know. Little chamfer with the live tool. Move to the dots, 6 little dots. Before I was doing a coolant through ejection, and now I've got the little plunger going. So it just kind of kicks the part out. Anyway guys, that concludes this video. it's been a journey. It's been stressful. I've been not a happy person the past week trying to dial this in, but now I know the machine so much better, and I'm really happy, really happy with how they turned out. And yeah, now we just make. Later. Bye.